basically look at substitution and get as much practice as we can. We're going to do what I might describe as obvious U-subs, and then we're going to look at some situations where it might not be that clear what the proper U-sub would be. Well, I'm not normally very good at distractions, so be extra vigilant and shout out when a 2 turns into a 12 or whatever I end up doing wrong. So let's look at some unusual U-sub situations. What U-sub would be a good idea to use in this question?
One over x.
1 over x. Is that because of this x here? Is that what you're thinking?
That and the derivative of 1 over x is the natural log of x.
Ah, I see. Switch that sentence round and you've nailed it.
I have it around. Okay.
That's your U-sub, log x. And if you use this as your U-sub, then when you differentiate with respect to x, you get that 1 over x thing that Kathy was thinking about. And I'm already going wonky. X d thingy bob gets you dx. Right. Oh, well, that one came out rather quickly. Log to the 10 gets me u to the 10 over an x, and the dx gets replaced by an x du. And so this is a good sign, isn't it, when you see these x's disappearing, because now what we have is u to the 10 du. And I'm just going to go dot, 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 dot with this one. Wouldn't you just use the power rule, 1/11th u to the 11, and then wouldn't you replace the u with log x and add a plus c and you're done? So typically when you get to this stage, it's pretty rote, right? It's pretty standard what you would do to complete the question. So the trick is really choosing a good U-sub and then seeing, where to, to get to this line. And when it gets to this line, it should be a standard integral that would be in that table. So what makes this one a little bit weird, well, is this funny thing called a squared. The variable is x. I know it's x because dx tells me it is. So any other letter of the alphabet is treated as a constant. So that's not really a squared in the usual sense. It's more like 5 squared, just like a number. What's the U-sub that you would do in this question?
a squared minus x to the 5th.
Correct. That would qualify as ugly guy inside square root. Pick the ugly guy inside square root as your U-sub, right? Now, differentiating that, you have to be a little bit careful. If you differentiate this piece, you get negative 5 x to the 4. Nobody's bothered about that. What do you get if you differentiate a squared? Bearing in mind a squared is treated as a constant.
Zero.
You get 0. Yeah, 0. So when you do the crossover, and when you want to isolate the dx, You get that. So this fella becomes the integral of x to the 4, the square root of u, and the dx gets replaced, and I almost lost it, a negative, by a negative 1 over 5x to the 4 du. And exactly what we would hope. Don't you tend to get the leftover x's tend to get killed off? That's a very good sign. This fella here becomes negative 1/5, but instead of the square root of u, I'm going to write it as u to the half. So I'm not going to write this as negative 1/5 square root of u, but equivalent negative 1/5 u to the half. Why am I doing that?
So you can take the antiderivative.
Right, power rule, right? Can't do power rules as square roots, right? I need fractional powers. That's pretty much the only reason. So this guy here is ugly thing inside a bracket. That's why it's log x. This guy here is ugly thing inside the square root. So we're still following the rules of yesterday, right? None of these are special cases. I guess they're just ugly versions of a normal situation, right? Weirder looking guys. Here's another weird looking guy. Now, what makes this question a little bit different from the others is that there's a cube root of something squared going on, which we haven't really seen that situation before, and the fact that we know it's a u sub question, so we're hunting for who the u sub should be. And I guess there's a couple of candidates here, but before I even think about my u sub, I am going to take this fella here, right, this expression here, and I'm going to rewrite it like that. Isn't the cube root of something squared something to the 2/3? Isn't that the fractional equivalent? Now, actually, by doing that, haven't I removed a lot of the clutter? And so it should be a little bit clearer now who my u sub should be. I guess the choices are, is it the whole thing in the bottom or just the 8 plus 2x?
The 8 plus 2x.
Yeah. Technically speaking, isn't that the ugly thing inside the brackets rule? Now, for this particular u sub, it's actually a very simple u sub. Basically, don't you just get 2? You differentiate with x. And when you do the crossover, you get that. And when you isolate the dx, you get that. So this fella becomes 1 over u to the 2/3 times essentially a half. That guy, we can find the antiderivative of this guy. What's the problem? I need to write it in a format that's going to allow me to use a power rule. And right now it's not really written that way. So what power of u is this guy going to get turned into? Agreed. Would you agree at this point I can just do my ... thing? Because wouldn't this just be add 1 to the power, divide by the new power, and then do your usual 3 or 4 more lines? You're done. Oh, bear in mind that all answers get converted back into x's, so don't write down, because I've seen this so many times, it's disappointing, that you do all the hard work and you write down u squared plus c, when you should have written in brackets 8 plus 2x squared plus c, you know, that kind of thing. It's so easy to get caught up in the process that you're so happy that you got an answer that you forget your answer is in u's. And the last step is always get your answer back to x's. Now, if the question had from 0 to 1 in it or something, then wouldn't we find the antiderivative, plug x equals 0 and x equals 1 and subtract them? So that would just be an extra bit of numbering crunching that we would do at the end. Are we cool with that one? It's still the same as yesterday right now, right? It's still the rules of the u-subs. No special special exceptions, right? None of those. Here's another one which again is not an exception yet. I'm getting all the weird ones out the way and then we'll finish with exceptions, right? Or things that you have to deal with to make them work, right? Let's look at this guy. If you try to just work with what's in front of you, you'll never really get out of a hole. You'll go down a rabbit hole, you'll end up nowhere. Because this question requires us to realize that the best strategy for solving this question is to actually solve two questions. And let's look at each one in turn. The 7's not important. If that was 1 over 1 plus x squared, isn't that a standard antiderivative? Does anybody know what that one is? Because I don't have my sheet here anymore, because you're going to have to figure them out. What is 1 over 1 plus x squared going to get you?
Inverse tangent of x.
Right, so 7 of them just gets you 7 inverse tangents. Okay, I'm not going to finish this question here, but we will talk about it. Do you recognize that this one is a u-sub question? Right, that's how you're going to solve it. Great. What u-sub would you use on the second half of the puzzle, this puzzle here? Not a trick question.
Squared.
Yeah. Isn't it, when it's a fraction, use the guy in the bottom row? And can you trust me
that side of your paper?
Oh. What on earth is happening to my software today? Like,
there we go.
There we go. Right. Okay, we got it now. Plug it in and you get your answer. Okay. But it's still yesterday's. It's still one of the rules. The rules work. How about this one? Well, all the questions that I'm doing are actually versions of homework questions. This is not a special case. Well, I guess in a way it is, because trig are always special no matter what they are. But it is a u-sub. You don't need to do any trig identities this time. But you do have to pick the correct u-sub. Any volunteers? What u-sub?
Secant squared?
I think I know why you're picking secant squared. Aren't you thinking secant squared gets you a tan? But what way round should that go? Tan gets you secant squared. So you're in the right thought process, but you kind of got them back to front. Now let's see why that one works. Remember, when you do a u-sub, aren't you going to differentiate that u-sub? Not integrate it, but differentiate it. So you got to have your brain, you know, left, right, not right, left. Okay, that kind of thing. Now, if you differentiate a tangent, what do you get? Agreed. So that's secant squared. So when you do the crossover, you get secant squared dx. And when you isolate the dx, you get that guy. So let's see what we get. We get a secant squared theta. Oh, shooting space. I'm so busy thinking of x's, I forgot that it was a theta. But it's the same math, right? Exactly the same math. So I get secant squared theta. Tan cubed becomes u cubed. And the d theta becomes 1 over secant squared theta du. Do you see something really nice here? When that happens, isn't that typically, I must have picked the right use up? Now, in this case here, add 1 to the power, divide by the new power. And then remember to return back to the theas. So, Arwen, I'm going to pick your brain for a minute. When you went and chose secant squared, were you thinking secant squared got me a tan and not tan got me a secant squared? Right? So you had the right process. Your brain was thinking the right way. And you have to just make sure you get it, you know, you pick the right U sub to make that happen, right? But that was the hardest part, I would say, you know, moving these too quickly. That was the hardest part, trying to figure something out. So let's look at special cases now. Or weird cases, I guess. I need a U sub for this question. Weird thing at the top here, but we'll worry about that in a minute. What would be the typical U sub to do in this question? Because I'm going to show you two flavors of it. One is kind of like yesterday, and one of them is going to be brand new, slightly different special case today. What would you normally do if you've got a fraction? Would you agree the U sub would be the guy in the bottom? So let's use that guy as our U sub. Now, all I'm doing here is rewriting cos squared x a little bit differently. Because when you differentiate cos squared x, don't you have to do a chain rule thing? What does that look like? Well, that gets you nothing. If you differentiate cos squared x, you get 2 lots of cosine x to the power of 1, but then don't you then have to do the derivative of cosine x, which is negative sine x, which means that du by dx is negative 2 sine x cosine x. Do you recognize, take out the negative, do you recognize 2 sine x cosine x? Trig identity, double angle. What is 2 sine x cosine x equal to?
Sine 2x.
So I'll just stick a negative in front of that. You happy about why the negative's there? Right, let's do the usual now. Do the crossover. And then you isolate the dx. So I have the sine of 2x over u times -1 over the sine of 2x du. The sine x cancel, and I get that guy. And isn't that guy a really, really nice standard integral? And that would get you negative log u, and that turns into negative log of 1 plus cos squared, and then you add c, and you are finished. Now I'm going to keep that question here, and I'm now going to replace it by one tiny change. It's not sine 2x in the top, it's only sine x. All bets are off now, special case. 1 plus cos squared, the entire bottom does not work. Can you see from this working here, you end up with a sine 2x, not a sine x. They're not going to cancel out. I've never, well, I can't say never. It's very, very unlikely that sine x is going to work, and it doesn't. But the question must be doable, so there needs to be a u sub. But there aren't any rules like guy inside, ugly guy inside square root, pick the ugly guy. There are no rules like that now. Each one is kind of its own little puzzle. You got to figure out its own unique way of doing it. What u sub do you think might work with this fella?
Cosine x.
And only the cosine x. Let's take it through the steps and see why. Oh, a little mistake that I almost made, but I caught myself. What's the derivative of cosine x? Plus or minus? Derivative of cosine.
Minus.
Minus, right? You know how many times I'll put a plus there when I know I shouldn't, but I get careless. Now, if you do the crossover, and then you isolate the dx, oops, pen's all over the place. It's sine x, 1 plus cos squared now becomes 1 plus u squared. The dx becomes -1 over sine x du. And you see that that matches perfectly with what we have left over. And that becomes this fella. But doesn't this guy is actually doable? Isn't this just a standard integral with a negative in front of it? And then replace the u with cosine x. This is the answer to that question. This is the other one. When you look at the two answers, do you see that they don't really bear very much resemblance to each other? They're quite significantly different things. And that was only by changing a sine 2x into a sine x. The u subs were different. The math that you did was different. The final answer was quite significantly different. Do you see how a small nuance, a little change here or a little change there can make a vast difference in what you end up getting and how you do it? So, have we go with that one? Let's show you another special case. Don't know why I went red. If this was yesterday, wouldn't the rule be when it's a fraction, pick the guy in the bottom? So the u sub would be 1 plus x to the 10. If this was yesterday, it probably would have worked. But it's today, and we are looking at special cases. And would you agree that 1 plus x to the 10 doesn't work with this question? And I just realized something. That's a 4. Yeah. What u sub does work?
X to the 5th.
Right. Now, there isn't even an obvious x to the 5th here, but that is the right u sub. So, Kathy, you want to share your thought process why you picked that?
Because x to the 5th squared would make it so we'd have a 1 plus a u squared in the bottom.
And that's a good thing to have, right? Agreed? Have you noticed that what do you get if you differentiate an x to the 5? Don't you get some version of an x to the 4? And doesn't that also match the top? So you put those two ideas together, doesn't that seem to be the right road to go, right? It matches the bottom well, and its derivative matches the top well, right? Those two together are perfect. So differentiate with respect to x. Crossover, and then isolate the dx. Now, to remind you what she said there, isn't x to the 10 basically u squared? Can you see that? It's like x to the 5 squared. So the bottom is 1 plus u squared. And the dx is 1/5 x to the 4 with the du. I tend to take these ugly fraction things and separate them out from the other piece. If you try and bring them together, like stick a 5 in the bottom, it's such a distraction that you might write something wrong down. And so when I look at this, I just say, oh, okay. Do you recognize it as an inverse tan with a 5th stuck at the front? So we have a 1/5 inverse tan. And then just replace it by that fella. Agreed? How about this fella? Special case, exception to the rule. If it was yesterday, wouldn't the u sub be x log x? But derivatives of x log x probably aren't going to play well with what we've got left, agreed? So I need a different u sub that's going to work. Any suggestions?
ln of x.
Okay, you want to share your thought? That's correct. Do you want to share your thought process for why you picked that, Sam? I can't hear you.
Sorry. The derivative of ln of x is 1 over x. And when that is flipped, it'll cancel out the x in the bottom.
Great. Exactly how you should see that question. That's perfect. So we'll differentiate it. We'll get this guy. If you cross multiply, actually, yeah, there's an exception to the usual 4 lines of working. Sometimes you get lucky and get 3. So this is going to be a 2, an x, and a u with an x to u, which gives me 2 over u 2 natural logs plus c. Oh, that's a weird answer. The natural log of another natural log. It's a weird looking answer, but it's correct. Are we good with that question now? Can you see the exceptions to the rule are not standard, they're just different. Each one of them is kind of different from the next one as well, right? I need a U sub. Ah,
Cosine t?
and only cosine t, right? Not cos squared t. And can I trust you can do the work and it works, right? There's going to be a question in the homework that looks like this guy. Negative 66, so some big ugly function dx equals 0, and it asks you, is it true or false? So I guess you could guess until you got it right, because you get 3 shots and there's only 2 answers, so you're going to get it right eventually. But if you want to know how do you do it, you plug it into your calculator. The ugly function. Now, if the ugly function is what we call odd, odd means if you turn upside down, it's the same. Or in this case here, do you see that that bit is the same size? Wouldn't that be a 0 situation? But if the function is different on both ends, can you see that that's not, and that's false? So whatever the ugly function is, just put it in your calculator and have a quick look from negative 66 because of this. And if it looks what we call an odd function, right? That if you turn it upside down, it looks the same. The answer will be 0 every single time. And if it's not odd, won't it be some other number that's not 0? For the last situation that we're going to look at, and that's basically us covered substitution method, are guys that look like this. Now, it's not that the substitution is a problem, it's what happens later. What would be yesterday's U sub for this? What would we have chosen as our U sub in this question? Because it's the same answer. It is the same U sub.
2x plus 1.
Right? Isn't it ugly guy inside the brackets row? So this is not an issue. It is the correct U sub. You get 2. Cross over and isolate the dx. Nothing strange has happened yet. Then you go over here and you do x, and that guy becomes u to the power of 10, and the dx becomes 1/2 du. Do you see that we have an orphan x? Shouldn't that x normally just be cancelled out by some other x? And we see that all the time. In fact, normally that is how we decide we've picked a good U sub. But sometimes you will get an x left over, and it's not that you've done it wrong. So you say, well, how can I cope with it? Because I need that to be u's, right? I need everything, including this x, to be in terms of u. So what you do is you use your U sub to find out what x is in terms of u. So if I subtract 1 from both sides, and if I divide everybody by 2, then won't x be that guy? Which means I now have 1/2 u, take away 1/2, u to the 10, oh, another 1/2, du. Now, I can integrate that in a minute, but won't I have to distribute everything to get it into powers of u so I can use, the power rule? So 1/2 times that gets me 1/4 u to the 11. 1/2 times that gets me negative 1/4 u to the 10 du. Would you agree that that is now a doable question and ... Okay, let's look at another one where this leftover orphan thing happens, right? Another situation where this happens. Do the integral of x, the square root of x minus 4 dx. Now, yesterday, the rule is ugly guy inside square root is your u sub. I mean, it's not that ugly, but it is the u sub. Now, if you do the derivative with respect to x, don't you get 1? And the crossover, oh, we're finished. So we now have x, the square root of u, du. Do you see we have the orphan x guy? Well, if you rearrange this, won't x be u plus 4? So now we have u plus 4 square root of u du. But I can call that guy u to the 1/2. Okay, remember, I think probably at the beginning of the week, didn't we do these kind of guys? So in order to be able to find the antiderivative of this, didn't I need to turn this into a 1/2 power? But in this case, won't I also have to distribute it? So u times u to the 1/2 is u to the 3/2, and 4 times that guy is 4u to the 1/2. And at that point, we are done. Because can't you use the power rule and all the other good stuff that comes with that? Okay, hopefully I've done enough examples here to give you a good bit of help for your homework. So for the rest of what's here, take attendance. Will you say hi? We'll do it now. Some of you may have a class to go to. If you do have a class, come back and watch the rest of this video, because what I'm going to talk about now is your test and what you're going to do and so on and so forth, right? So far, so good? Right. Now, I had this issue with my other class. I don't know if I'm going to have it with you lot. 11 till 1. Is 11 to 1 going to interfere with anybody's classes? So you are good. 11, normal class time. Instead of finishing at 12, you're going to finish at 1. Or when you are thinking face on, are you thinking that that would interrupt with you or not? It's on Monday. Are we good? Okay, we're good. So what's going to happen then is that you're going to turn up, and on Monday, in usual class time, you're going to have a Zoom meeting like this, and I'm going to see you all, because you'll put on your videos, and that way I can check that you're not getting your answer from your big brother or your little sister. Right, so that's my first check. It's on WebAssign. It's basically going to appear at 11 o'clock. So if you go to WebAssign at 2 minutes to 11, you're going to come on to Zoom and say, your test's not there. And I'll say, you're right. And at like 1 second past 11, it will suddenly miraculously appear. And then you will start doing it. And it's just like doing a test in class, right? I'm handing you out the bits of paper, the test, and you do it. Now, because it is on WebAssign, you only write in answers to boxes. You know how the usual WebAssign gives you a question, but you only write, 2x plus 1 plus c or something, that kind of thing. You will do that. But what's more important is you will do working on paper. And when that test is finished, I want you to keep that working that you've been doing for all the questions that you found working was necessary for, right? There might be some questions you do in your head. If you're doing the integral of 4 over 1 plus x squared, you're probably just going to say 4 inverse tan, right? Because there isn't anything to do with that. But would you agree if you're doing a real substitution question, won't there be a good 5, 6, 7 lines of working that you would need to get your answer? So those are the questions I'm really talking about, right? Do you know that you're going to get one question, and I guess one is thankful, on that horrible number crunching one? Do you know the ones where here's a table or a function, get M6, R6, less 6, T6, and S6, right? That kind of question. You're getting one of those, right? All I will be saying as far as working goes, because you're not going to write down every calculation 8 times, but I would say a table of values, right? I would say a table with the numbers that you're going to use. And S4 equals 22.1. I would prefer you to at least tell me what you were trying to add or multiply in case you screw up in your adding. But I'll see you're working. So how are you going to get that working to me? That's the problem, right? It's on pieces of paper, and you're not going to post it to me. That wouldn't work. You're going to use a piece of software called Adobe Scan, or you're going to use another piece of software that you've got that basically you use your phone and you take pictures of your 5 pages where your working is on. And this piece of software called Adobe Scan allows you to convert that into a PDF, right? That PDF is what I'm going to see. You're not going to email me that unless all else fails. What you're going to do is you're going to upload that onto Canvas. So on Canvas, there's going to be this little link, and it will say to you, upload your working to test 1 here. And when you click on it, it's pretty self-evident what you do. There's a little box called File. You hit it. On your desktop, you'll have your PDF. On your computer, whatever it is. You pick it and it uploads it, and you're done. Right, so that's how that's going to work. So you're going to do your test. You're going to do relevant working. You're going to take a copy of that working, turn it into a PDF, and upload it into Canvas so I can get it. So a couple of reasons for that. First one is stops cheating. If I know a question needs 10 lines of working and you just tell me the answer's 42 and it happens to be correct, I'm just going to assume that you went to a clever piece of software and did it that way. And so if I don't see working, you didn't do it. That's to make things fair, right? Everybody should be treated the same. You don't want somebody getting an A when they don't deserve it and you fought hard to get a B. That's just not right. Or fought hard to get an A, right? The other reason is for your benefit. Do you know if you type in 42 into WebAssign and the right answer is negative 42, WebAssign will give you 0 points out of 20. But I will look at your working, and if I see that basically you did the process correct, but there was a little arithmetic mistake, you lost a sign or something, you'll get 18 out of 20 rather than 0 out of 20. So that's going to be a big plus to you. And I can tell you through experience, without fault, I can't think of an exception. If you show me working, you end up getting more points than you would have got if you just left WebAssign to give it to you. I guess the only exception would be if you got perfect. But as long as I see the working and it's perfect, then you are getting 100%. So that's your main guy. Zoom will be on during that time. This meeting will be on. So if you get a problem or a question that just doesn't seem to work, or you think WebAssigns went wonky on you, tell me about it and I'll see if I can fix it. Any questions about the test itself?
There's some in the chat.
Oh, thank you for telling me. I guess, it says a few people might not be able to do it. Someone here says I have a class starting at 12:30 and others get a class at 12. Let's talk about the times. If you are having an issue with that time slot, will you email me the 2-hour time slot that is going to work for you? And what I will do is I will go into WebAssign and customize it for your time slot. I can do that. It's a bit of a pain, but it's not your fault. I can do that. So if it doesn't quite work, like I got a class at 12, then I could make it 10 to 12, right? I could do it that way. If that doesn't work, then tell me when you are free and we'll figure out a time slot. Okay? Are notes allowed? Yes. If it's on a piece of paper, so you know that little sheet you have with the standard integrals, I'd probably keep that one handy for starters. I'd probably keep another one that has all the nice trig identities that you may or may not quite remember. You aren't allowed to communicate with people, so you can't go onto e-tutoring and ask Kathy, for instance, although I don't think she would be there at the time, she'd be doing the test too. But you're not allowed to do e-tutoring, you're not allowed to phone up your friend or anything like that. That is it. I'm being asked how many attempts. You're only allowed one attempt and it won't tell you if you're true. But that won't matter because you will show me the working. So basically, the WebAssign allows me to see what your answer is, and then I will check it against your working. And if your answer is wrong, but the working process is correct, you'll get the majority of the points and you shouldn't worry about it. In fact, if your working has the right answer down, let's suppose you did the working and the answer is 24, but in the heat of the moment, you typed 42 into WebAssign, right? Your working was right, I'll give you all the points. If the answer at the end was right, I'll give you the point. You know, sometimes it's on the paper and then you transfer it to the computer and you lose something. Right? You forgot to write an x squared down. You know, you put a plus and you knew it was a minus. Hey, I see the working, it's cool. You won't know if you're right or wrong. WebAssign will just take it and run with it. You only get one shot. You won't get any, can I see questions like it? Is there a video I can watch? That will be taken out. You won't be able to look at your previous examples that you've done because that'll be blocked out as well. So all you'll be able to do is anything that you've written as notes and what's in your brain. Any more questions? I'm looking at the chat in case there's more.
Are we going to need all of the time that we've been allotted, like the full 2 hours?
Yes and no. Some of you will be finished in over an hour, and some of you will be writing frantically up to the last second. So it depends on who you are, right? So if you do things quickly, you'll be finished in plenty of time. You don't design your test for the slowest person, because I've done tests I've done quizzes that should last half an hour, and some people would take 3 hours doing it if you let them. So that's just not practical. So 2 hours is plenty of time for a typical student to get that done. Another email issue. Email me if you get special requirements, because some of you I get extra time on a test. Right? So you email me, I'll try and say that again. You email me that, and I will make sure that you get the extra time allocated to you. Okay? If that happens to be anybody in this class. Any more questions? Because they're good questions.
There's a few more in the chat.
Okay. Yes, all Monday tests will be the same size. Is Desmos allowed? Desmos can be used to graph things and to do tables of values. You know, like if you wanted a table for S4 or T6, yeah, that's allowed. Calculators are allowed, yes. Notes are allowed, yes. Any other questions? Test is chronological. The first thing you're going to see is going to be, you know, find T6, R6, and S6, and here's the table or here's the function, right? And the last question you're going to get is integrate this guy, but you're going to have to use the substitution rule. Okay? I'm trying to think. Last few seconds, last few minutes, whatever. Anything else?
Looks like someone wants to know how many questions are on the test.
Can't remember. I could go and look, but with my luck, if I went and looked right now, you'd see the questions in the test. God, how many sections are there? Is there about 7 sections we've done? Oh, 6 sections. My guesstimate is there's probably going to be about 12 questions. Okay?
I had one more question.
Sure.
To practice for the test, would it be best to just go over the homework problems again? Like, is that going to be the most similar as the test?
Go over those homework questions, look at the kinds of ways they're phrased, because WebAssign basically does things its own way, so it phrases questions its own way. What you'll end up seeing in your test will look like homework questions similar to things I've seen before. Okay, there'll be an x cubed where there used to be a sin x or whatever, but it'll be in the same family. The test is designed that it's almost unique. So even if you try and cheat, you won't be able to, because your question 4 won't be Arwen's question 4. So even if you phone up her and say, what did you get? She'll tell you it's 42, and if you type in 42, you'll be wrong, because it won't be the same question. It's to be fair. I think everybody wants to be treated fairly. So if you all get treated the same, it seems to me the best way to do this.
There's also those practice quizzes that are in a resource tab. Are those something
go
that we should
for
look
it.
at?
I haven't looked at them, but
Okay.
yeah. WebAssign, you might not know it because you don't get to talk to each other or see each other's stuff, but you know the homework that you do? Arwen, your sister does homework as well, right? And you know you're allowed to check the homework. Have you noticed that you might get 5x cubed and she gets 6x squared? So you know, even within your homework, WebAssign randomizes the questions. So it's good practice just to look at your questions. I don't know what you're talking about in that quiz thing, but I'm sure that's a cool thing. Have a look at it. I don't think there are any problems with that.
Yeah, it doesn't affect your grade at all, but it shows you if you're on the right track for the way they want things solved.
Okay, sounds like a good resource then. Whereabouts is it, Kathy? I mean, that I haven't looked, so I don't know. You'll have to hit the space bar. You've gone quiet.
If you're on the home page of when you sign in and you click for our class,
Yeah.
you scroll down. I think it actually has the name of the book on that line. So it's under our assignment list.
Mm-hmm. And then there's just a link to practice test or whatever they call it.
Yeah.
Cool.
Yeah, it's in there.
Go there. It's a good place. If you got time, try it out. I'm assuming it does like WebAssign. You put in the answer and it tells you if you're right or wrong, or does it do more than that?
Let me read that. It says personal study plan.
Okay.
And then you'll take the quiz. The quiz, when you're taking it, won't tell you if your answer is right or wrong until you're done and you submit it.
Which is what WebAssign does in its test. So it's very similar to what your test format will look like.
Yes.
I can pretty much guarantee my test won't be that, but it'll be very similar to it. There'll be some stuff they've got that I've not, and there'll be some stuff I've got, and vice versa. But it's go for it. I have no problems with that. Any other suggestions for people out there to help each other? Because that was a great one I never thought of. Look over your homework. Alia says that's a good idea, right? Look over stuff you've already done. Kathy's idea of doing that practice review test, whatever it's called, that sounds like a good deal. Is there anything else in WebAssign? Because my version's not what you see, where it gives you extra questions to do just because you want to. Is there a feature there where you can just say, "Can I practice some more?" Feature, something like that.
I know that in each question itself, there's like a button that says practice another, where you can just practice a different version of the same question.
Okay, so you can do that even for homework that's finished, that's graded. So there's another thing. So when you're doing Alia's thing of looking over the homework and you think, yeah, I'd like to do another one like that, maybe you could hit that button and try it out and get a bit more practice on it. That would be a good way of preparing. I think we've covered everything.
There's also a button that says My Class Insights, where it actually tells you what subjects, what topics you had issues with, and if they have another question, it will have an opportunity for you to practice another question.
Oh, where is Class Insights? Is
My
that in
Class
your
Insights, again, it's on the home page when you first get in there, and it's on the right-hand side above the announcements.
Okay. So there's a link called Class Insights. So I'm assuming you go to Class Insights and it says you had problems with question 9 and things like question